Hello everyone. Today we are going to summarize chapter 1, number system. At first, the definitions of rational and irrational number. A number is called a rational number if it can be represented at p by q form, and where q should be non-zero. And a number that cannot be represented as p by q is called irrational number. So all the rational and irrational number collectively called the real numbers. We know that. And the decimal expansion of the rational number is either terminating or non-terminating, reoccurring. Okay, the condition is reoccurring, right? While the decimal expansion of a irrational number is non-terminating, non-reoccurring decimal, right? So we have some properties here, and you have already studied these properties, where the product of a and b taken in the root is same as the product taken with separately roots. So root a into root b, we know that. This is root of a divided by b can also be written as root of a divided by root of b. Now here root a plus root b into root a minus root b, you know that this is a plus b was a plus b into a minus b, that is equal to a square minus b square. Root a square is a itself, you know that, and root b square is b itself. So you can write a minus b, right? Now in this a plus root b, a minus root b we have given here, a plus b into a minus b we have given. So a into a is a square minus root b square is, you know that this is b. So you can write a square minus b, right? Now in the previous classes we have studied, when we have given same bases to multiply with the different powers, the power will add, right? The number having double power will multiply, when you divide same bases with different powers, the power of divisor will be subtract from the power of dividend, so p minus q will be there. Now different bases with the same power, if you have given, you can multiply the bases and give the same power, right? So these things you have done in previous classes also. Now come to this question, which of the following is not equal to? So we have to find not equal to. So at first we will solve this. So here you have given 5 by 6 raised to power 1 by 5 and minus 1 by 6. This is the case when we have the same base we have a number with the double power, means two powers are there. So at first we will multiply the powers. This is equal to 5 by 6 raised to power minus 1 by 5 6 are 30. This is 30. Okay, so let us check. This is minus 1 by 30, so you can take reciprocal to make the power positive. 6 by 5 raised to 30. This is same. This is 5 by 6. This is 5. This is the same. This is same because we have taken reciprocal, and this we have find 5 by 6 raised to minus 1 by. Okay, here 1 by, because we can take the reciprocal of the base to get the positive power. This is also right, but this is wrong. So option A is not same, right? Now come to question in the exercise question 1. Every rational number is a real number, you know that every rational number is a real number. Come to next question. Between two rational numbers there is no rational number. This is wrong. There is exactly one rational number. This is wrong. There are infinitely many rational numbers, is right. Okay, come to third question. Decimal representation of a rational number cannot be. We have to find cannot be for the rationals. So it is terminating, non-terminating, repeating, non-terminating, non-repeating. This is for the irrational number, right? Now come to question number 4. The product of any two irrational numbers is always a rational number, always a rational number, always an integer, sometime rational, sometime irrational, right? D part is right, because when you multiply root 2 with root 2, what you get? This is root 2 square, and this is equal to 2, which is a rational number. Okay, right? But when you multiply root 2 with root 3, both are irrational number. When you multiply, you will get root 6. Root 6 is irrational number, so it is sometimes rational and sometimes irrational. So D part is right. The decimal expansion of the number root 2 is directly, we know that this is 1.41421, right? So you can write it, you can take it directly. Which of the following is irrational number? Okay, when you solve 4 by 9 under the root, you will get 2 by 3. This is a rational number. Root 12 can also be written as 4 into 3, okay, by 3, because I'm taking complete root, so you can cut 3 by 3. This become root 4. Root 4 is equal to 2. So this is also not a irrational number. Now third part we will check root 7. Root 7 is irrational number. Root 7 is irrational number. Let us check the next one. Root 81 is same as 9, because 9 is a rational number, right? So our answer is C part. Now come to question number 7. Which of the following is irrational number? We know that according to the definition of irrational number, a non-terminating, non-recurring decimal is a irrational number, right? So let us check 0.14. It is terminating, so it is rational number. So 0.1416, here is the repetition of 16. Here is recurrence of 16, so it is also a rational number. Here is recurrence of 1416, so it is also a rational number. But we see 0.401, 4001, 40001, so there is no recurrence and it is not terminating because it have dash 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 at the last. So irrational number is D part, right? Now come to question number 8. A rational number between root 3 and root 2 and root 3 is, if you are asked to find a irrational number, we can directly write root 3 plus root 2 by 2, but here we have asked a rational number, so at first we have to check the expansion of root 2. So root 2 is 1.412 something, and root 3 is 1.732 and something. These are two non-terminating decimals. So if you check, 1.5 lies between 1.4 and 1.7, so our answer is 1.5, because 1.8 is more than 1.7. It can't lies between these two, so this is the wrong one. When we find root 2 plus root 3 by 2, this is again an irrational number, but we have to find the rational one. Here if we find roots 2 into root 3, that is root 6 by 2, it is again an irrational number. So 1.5 is a rational number because it is terminating decimal, and it lies between root 2 and root 3 also, right? So C is the right answer. Now come to question number 9. In the question number 9, we have given, okay, these are the questions that we will do with the separate video. Okay, for this time we can say this is C is the right option. Okay, now come to 10th question. 2 root 3 plus root 3 become 3 root 3. Root 3 is just like a, just like a irrational number multiplied with the coefficient. So 2 plus 1 is 3, and root 3 will be written with it, right? Now root 10 plus root 10 multiply root 15 is equal to, so it can also be written as root 10 multiply root 15. Okay, root 10 can also be written as 2 into 5. 15 can also be written as 5 into 2. So sorry, 5 into 3. here we have 5 square, so it will come outside the bracket, and 2 3s are 6 will remain in the bracket. So 5 root 6. So let us see which option is showing 5 root 6 is B answer. Now the number obtained on rationalizing this. So you know that when you rationalize, you will change the sign between in between the rational and irrational number. You have again root 7 plus 2 you will get. So I'm sorry, so here root 7 plus 2, right, root 7 square, that is 7, minus 2 square is 4. So you will get, you will get root 7 plus 2 by 7 minus 4 is 3. So A is the right answer. Okay, now come to next question. Again we have to rationalize and find the value. This can also be written as, so take the rationalization, root 9 plus root 8. We will just change the sign of in between them, and root 9 plus root 8, same with same number we will multiply and divide, right? So on the numerator part we will get root 9 plus root 8, and in the denominator we will get 9 minus 8 is 1, means we have root 9 plus root 8. So let us solve root 9 plus root 8. Root 9 is 3, we know that this is 3 square is 9, and square root will be cut. Root 8 can also be written as 2 into 2 into 2 means 2 root 2. So see which option shows you 3 plus 2 root 2. This is option number D, right? Now come to next question. After rationalizing the denominator, we get the denominator is, okay, we just tell the denominator after rationalizing. So after rationalizing you will get 3 root 3 square, that is 3 3s are 9, 3s are 27, and 2 root 2 square, that is 2 2s are 4 2s are 8. When you subtract 8 from 27, what you get? 17 minus 8 is 9, you will get 19. So B is the right answer, right? Now come to 15th question. The value of root 32 plus root 48 by root 8 plus root 12 is same as, okay, so if you can take common here, you can take, if you want to take common you can take here. So this is 8 4s are 32, you can take, and this is, okay, right, 32 is 8 4s are 32 under the root, and 48 as 12 4s are 48, right? So you know that square root of 4 is 2, you can write it 2 root 8, and you can write 2 root 12, right? This is the numerator part. You can take 2 as the common outside, so you will get 2 into root 8 plus root 12 inside the bracket, and in the denominator you also have root 8 plus root 12, right? So these are same values cut, only 2 will remain. So what is the solution of this part is root 2, sorry, only 2. So now you have given the value of root 2, and you have to solve it. At first we will do the rationalization. Always we will do the rationalization at first in these type of questions. So take root 2 minus 1 by root 2 minus 1 under the root, right, under the root. So this is equal to same basis root 2 minus 1, so root 2 minus 1 square under the root, square is there, and in the division root 2 square minus 1 square under root, right? So what you get here, root 2 minus 1 square and square root will cancel, you will get root 2 minus 1 in the numerator, and in the denominator root 2 square means 2 minus 1, that is 1, and square root of 1 is 1. So means you will get root 2 minus 1 here, right? So after solving it, we get root 2 minus 1. Now put the value of root 2 here, 1.4142. Okay, 1.4142 minus 1, and what you get, this is 0.4142. So let us check which option shows you 0.4142. This is C option, right? Now come to question number 17. Okay, we know that if we have given like p under the root x raised to q, you can write it x raised to q by p, right? X raised to q by p means the power that is outside this under root will take as the denominator inside. So at first we will solve this part, 3 root 2 square. This is equal to 2 raised to 2 by 3. Okay, right? Now it is outside 4, so 4 will also come in the denominator part. Now cut 2 ones are 2, 2 twos are 4. This will equal to 2 raised to 1 by 6. See which option is showing you 2 raised to 1 by 6 is C part, right? Now come to 18th question. We have to solve this. Again we will write 2 raised to 3 by 2, because root means 1 by 2 and outside 3 means 3 by 2, multiply by 4 raised to 1 by 4. Just a minute, let me show you in smaller way. Okay, so 3 root 2 can also be written as 2 raised to 1 by 3. Okay, and 4 root 2 can also be written as 2 raised to 1 by 4, and 12 root 32 can also be written as 32 raised to 1 by 12, right? Now multiply them. So just multiply them. 2 raised to 1 by 3, multiply. This is 2 raised to 1 by 4, multiply. 32 can also be written as 2 raised to 5. So 2 raised to 5 by 12. See, all the bases are same and multiplied. So you can add the powers. So it will equal to 2 raised to 1 by 3 plus 1 by 4 plus 5 by 12. So what is remain here to add? 1 by 3 plus 1 by 4 plus 5 by 12. What will be the LCM? It is 12. 3 4s are 12, 4 3s are 12, 12 1s are 12, so 5 will be there. 5 and 3 8, 8 and 4 12. So 12 by 12, when you cut you will get 1. So it is 2 raised to, what was the base? Base was 2 and the solution of power is 1. So this is equal to 2. It is the right option. Clear? Now come to next question. So come to next question. This is question number 19. So 81 we have given. So this can also be written as 81 raised to power minus 2 by 4, right? So you can cut here. This is 81 raised to minus 1 by 2. So 81 is 81 can also be written as 9 square into minus 1 by 2. Cut this one. So what we have remained here? 9 raised to minus 1, and 9 raised to minus 1 means 1 by 9. See what option is showing you 1 by 9 is A, right? Okay, come to question number 20. Here we have given 256 raised to 0.16 into 256 raised to 0.09. So at first we will do the power solution of the power. We have given 0.16. When we have same bases multiplied, so power will be add, so you will get 0.25, and after solving 0.25 you will get 25 by 100. Just cut 25 fours are, so 1 by 4 you will get as the power. And 256 can also be written as 4 raised to 4. You know that 4 fours are 4 fours are 16, 16 fours are 64, and 64 fours are is 256, right? So what we get here is 4 raised to 4 into 1 by 4. If you cut it, you will get 4. So which option is showing this? A. So A is the right answer. Which of the following is equal to x? We have to solve and find which of these is equal to x. So let us solve at first this first part. We have x raised to 12 by 7 minus x raised to 5 by 7. These are subtracted, so we can't have x from here. If they are multiplied, we can add the powers and somehow we can get x. So see here, this is x raised to 4 by 3, x raised to 4 by 3, right? This is x raised to 4 by 3, this one, and 1 by 12 will come. 4 3s are 12, we will get x raised to 1 by 9. This means this is also not. So see this one, x raised to 2 by 3 again. So x cube and 2 by 3. X cube means after solving this we will get x cube by 2 into 2 by 3. When we cut, we will get x. In the next one, x raised to 12 by 7 plus 7 by 12 will be there, and if you add these two you will not get x. So the right answer is C. Clear? Now come to next. Are there two irrational numbers whose sum and product both are rationals? Justify your answer. Okay, let us take some example. 3 plus root 2 and 3 minus root 2 are two irrational numbers. When you add them, root 2 will be cut by root 2 and you will get 6. And if you multiply, 3 3s are 9 minus root 2 square is 2, that is 7 you will get. That is also a rational number. So we have two irrational numbers whose sum and product both are rationals. Means any number you can take with a different sign. Okay, same number with different sign. Now come to example number 2. State whether the following statement is true. There is a number x and such that x square is irrational but x4 is rational. Justify your answer by giving an example. This is true because if you take x is equal to 4 root 2, you can take here. So taking square on both sides, after taking square on both sides, what you get? This is root 2. Root 2 is the irrational number. If you get power 4, then you will get 2. And we can say that if we take a number x such that x square is irrational, x raised to 4, and the best example is 4 root 2 you can take, or x you can take here, y you can take here. So come to exercise 1.2. So see first question. Let x and y be rational and irrational numbers. Let us take x rational like 2, y irrational like root 3 you can take, or any number you can choose here. So find x plus y. X plus y will be equal to 2 plus root 3 is a irrational number. So it is 2 plus root 3, that is irrational number again. Second question, let x be the rational and y is irrational number. Xy is necessary irrational. Justify your answer. Let us take x as again. I am taking the previous example. X I am taking root 2. Sorry, x I am taking 2 2 and y I'm taking y equal to root 3 I'm taking. You can take any number. So let us find xy. This is equal to 2 root 3 is irrational, but in some case if I take x as 2 rational number, y as root 2 is irrational number. If you multiply them, xy equal to 2 root 2, that is again a irrational number. So come to question number 3. State whether the following statements are true or false. Justify your answer. See, root 2 by 3 is a rational number. No, it is p by q form, but here root 2 is not an integer. There are infinitely many integers between any two integers. It is wrong, right? It is wrong because if you take 2 and 3, okay, 2 and 3, there is no integer in between them. If you take 2 and 3, there is no integer in between them, but there are some decimal numbers in between them. They are rational or irrational numbers, okay, they are not integers. So third is also false. Second is also false. Number of rational numbers between 15 and 18 are finite. See, in between 15 and 18 there are infinite rational numbers. This is also false. There are numbers which cannot be written in the form p by q. Q should not be 0. P and q both are integers. Yes, it is true. It is true because बहुत सारे नंबर ऐसे होते हैं जिनको आप p by q फॉर्म में नहीं लिख सकते हो, ठीक है. जैसे इरेशनल नंबर्स को आप p by q फॉर्म में नहीं लिख सकते हो. A square of irrational number is always a rational number. It is the square of irrational number is always a rational number. Let us take root 3. If you find square of root 3, you will get 3. Yes, it is a rational number. Root 12 by root 3 is not a rational number, as root 12 and root 3 are integers. If you solve, root 12 can also be written as 4 into 3. Okay, let us take in same square root sign. Cut this 3 by 3, will get root 4. Root 4 is 2. 2 is a rational number, so it is false. Now come to seventh part, root 15 by root 3. Also root 15 can written as 5 3s, and if you take it in the same square root sign, 3 will be cut by 3, will get root 5. So root 5 is an irrational number. So we can say that this is false, right? Now classify the following numbers as rational and irrational. You know that root 196 is equal to 14. We have earlier studied in 8th class that 14 square is 196 and square root of 196 is 14. Okay, this is 3 outside. 3 multiply root 18. 3 into root 18. If it is inside, then it have the different meaning, but now it is outside. So let us take 3 into 9 2s are 18. So 9 is square of 3 and square root of 9 is 3. So 3 3s are 9. Root 2 you will write, and 9 root 2 is irrational number. So this is rational, this is irrational, right? Now come to third part. Square root of 9 is 3 and root 20. Okay, you can cut here also. 9 1s are 9, 9 3s are 27. So 1 by root 3 you will get. Okay, 1 by root 3, and 1 by root 3 you know that is a irrational number, as it is the quotient of rational and irrational. So it is an irrational number. Now you can cut it by 7. So 28 by 343. If you write 28, cut it. 7 4 ja 28, 7 4 ja 28, and 7 9s are 63. 4 by 49 you get 4. Square root of 4 is 2 and square root of 49 is 7. It is a rational number. So what we find here, this is rational, this is irrational, this is irrational, and this is rational, right? Now come to question number. Okay, some more parts are there. See, 0.4 can also be written as 4 by 10. You know that if you take square root, you will get 2 by root 10. So as it is the, if it is negative, okay, it is positive, then it is also okay. So 2 by root 10, it is the quotient of a rational and irrational, so it is a irrational number, right? So it is irrational. Now root 12 by root 75, and 12 and 75 both are cut by 3, so 3 4s are 12, 3 4s are 12, and 3 2s are 6, 3 5s are 15, 25 you will get. Square root of 4 is 2, you know that, and square root is of 25 is 5, so 2 by 5 is a rational number. So you can say that this is a rational number. This is rational. Now 0.5918, it is terminating decimal and terminating non-occurring, okay, non-reoccurring, but it is terminating. So terminating decimals are rational numbers. When you solve 1 plus root 5 minus, if you open this bracket, this become minus 4 and this become minus root 5. This minus root 5 cut by positive root 5 and you will get minus 3. Minus 3 is the rational number, so it is also a rational number, right? Now see, 10.124, so it is non-terminating and recurring decimal. Okay, non-terminating and recurring decimal. So a non-terminating recurring decimal is called rational number. Okay, and this is non-terminating non-recurring decimal. Non-terminating, this is terminating but non-recurring decimal, so this is also rational number. Now come to last part, 1.0100100. This is non-terminating but non-recurring decimal, so it is irrational number, right? Now come to next question. Okay, next questions we will cover in separate video, because these are very lengthy questions, and lengthy questions cannot be covered in whiteboard videos. So hope you learn something from here. Thank you and have a wonderful day.